Question 2. Question 2 also asks us to collect the definition of properties of stochastic process. And there are 8 stochastic process. So for the first is y-sense stationary process. If it means is a constant and autocorrelation is a function of time difference. So y-sense stationary process only uses mean and autocorrelation. In practice, they were much easier than get than second order density. Based on the mean and the autocorrelation function, we can do many things already. We can do state estimation, parameter estimation, and prediction, something like that. And the second is independent increment process. Means xt1 minus xt2 and xt3 minus xt4 are non-overlapping intervals or independent. So far we see that Poisson process, random walk, Wiener process, and independent increment process. It seems independent increment property is somehow related Markov process. And the third we say is Markov process if the past has no influence on the future when the present is known. And the first one is normal process, which is Gaussian. Process xt is said to be normal if the random variables are jointly normal for any n and any t1 to tn. That is like this. T1, T2, Tn, T1, T2, Tn equals 2. This is what we have, where and the sixth one is white noises. For Wiener process Wt, if we wish to discuss its derivative Vt equals to dWt dy dt, we have the expectation that Vt equals to dWt dy dt equals to 0. And we also have T1 equals to T1 minus T2. Wiener process Wt does have derivative. We use Vt equals to dWt dy dt just as a notation. When we need to do further discussion, instead of Vt dt, we use dWt. Wt is continuous with probability 1, and it has differential dWt, and Vt equals to dWt dy dt is Gaussian white noise with zero mean and impulse auto correlation function. We wish to define more general white noise with the zero mean and the impulse auto correlation function. And the seventh is stochastic process xt is said to be mean ironic process. And it's right like this. And for the ace is martingale, and which is like this. And that's it.